in order to display a binary number on two 7-segment display. Components required for this experiment is one comparator 74LS85, one adder 74LS83, two 7-segment drivers 74LS47, two 7-segment display. First, I want to tell you that this experiment is divided into two parts, Experiment 7 and Experiment 8. In Experiment 7, I am going to describe comparator and adder, and in second part, which is Experiment 8, I will describe 7-segment driver and 7-segment display. So let's begin with comparator. 5 is a comparator which is used to compare two 4-bit inputs A3 to A0, B3 to B0. A3 is MSB, A0 is LSB. Pin 2, 3, 4 are cascade inputs pin. Pin 5, 6, 7 are cascade output pins. 8 is a ground, 16 is a VCC. 2, 3, 4, which is a cascade input pins, is used to make comparator work in three different ways. A is less than B, A is equal to B, A is greater than B. In this way, we will compare two inputs in three different manners. We hard coded the input B to 9 in binary, which is 1001. We set B3 pin to 1, B2 pin to 0, B1 pin to 0, and B0 pin to 1. So now let's wire comparator and check that our comparator is working or not by using multimeter. This is my comparator 74LS85, and I'm going to check that my comparator is working or not by checking voltage across a pin using multimeter. I hard-coded the input B from B3 to B0 to 9. In binary, it is 1010. Let's check the voltage across their pin. B3, let's check voltage across the pin B3. As we are seeing that the voltage is 4.62. It means that pin B3 is working good. Let's check voltage across the B2 pin. Voltage across B2 pin should be 0. Let's check it. B2 pin is across pin 14. And we see that voltage is 0.0, so it means that it's working. Let's check pin B1. It's 0 volt. Let's check pin B0. It should be approx 5 volt. Yeah, it's 4.4, approx 5 volt. So it means that our comparator is working fine. Now we will check voltage across input A, means from pin A3 to A0, in which A3 is MSB and A0 is LSB. This yellow wire is connected to A3, this blue wire is connected to A2, this red wire is connected to A1, and this green wire is connected to A0. To check and one more thing, like we will provide any random input A value to our comparator. And how we will do that? By connecting this wire to VDD or a ground. Suppose I want to give input A as a 4 in decimal and its binary is equivalent to 0100 to a comparator. To do this, we will connect A3 wire, which is yellow wire, to a ground. Blue wire, which is A2, connect to VDD, means logic 1. Red wire is connected to ground. Green wire is connected to ground. By doing this, we are providing 4 as input A to our comparator. Now we will check by using multimeter. This is pin configuration of 74LS85. A3 is correspond to pin 15. Voltage across pin 15 A3 should be 0. Let's check it using multimeter. As we can see that it is 0 volt, so it means it's working fine. A2 means pin 13 should be 5 volts. Let's check it. Yeah, it is 5 volt, as we can see that. A1 should be 0 and A0 is also 0, so it means that our comparator is working fine. And output from comparator comes from pin 5. And why from pin 5? This is because we set the comparator that whenever A is greater than B, it's give logic 1, and whenever A is less than B, it's give logic 0 from pin 5. 83 is our 4-bit adder, which adds two inputs of 4 bits, A4 to A1, B4 to B1. A4 is MSB and A1 is LSB. By adding these two inputs, it gives us sum of 4 bits, sigma 4 to sigma 1. Sigma 4 is MSB, sigma 1 is LSB. C4 is our C4, which is pin 14, is our carry output pin. C0 on pin 13 is a carry input pin, which is set to ground. 5th pin is a VCC pin, and 12th pin is ground pin. We hard-coded the first input A4 to A1 to 6 in binary 0, 1, 1, 0, A4 to 0, A3 to 1, A2 to 1, and A1 to 0. Adder will add 6 whenever A is greater than B of a comparator, and adder will add 0 to the input A of a comparator whenever A is less than B. Output coming from comparator pin 5 goes into the input of a adder in pin A3 and A2. A4 and A1 is hard-coded to 0, 0. So whenever A is greater than B of a comparator, so pin 5 give logic 1, and this logic 1 goes into the pin A3 and A2 of a adder. So input A of adder becomes 0, 1, 1, 0 whenever A is greater than B. In decimal, it is equal to 6, and 6 will add into the input B of a adder, which is same as the input A of a comparator. And whenever A is less than B of a comparator, so pin 5 becomes logic 0, and logic 0 goes into the pin A3, A2 of a adder, and input A of a adder becomes 0, 0, 0, 0. In decimal, it is equal to 0, and 0 will add into the input B of a adder, which is same as input A of a comparator. Output of the adder from sigma 4 to sigma 1, in which sigma 4 is MSB and sigma 1 is LSB, goes into the first driver. And also Cout means carry out of the adder goes into the second driver. We will discuss about driver and 7 segment display in our next experiment, experiment 8, which is the second part of this experiment.